You know what it is. You are now tuned into the network, bro. Labbing on a Sunday, which is a rarity. Today's lab is NAT Overload. Y'all know typically I don't stream on the weekends. We usually stream Monday through Thursday, 8 p.m. Eastern Standard Time. But I said, I got some time this weekend. It's a holiday weekend too. My daughter's out of town and stuff like that. So I got a little bit more free time. You know, I'm going to be, exercising more, labbing more. Y'all know what it is, man. So hopefully you got the book. If not, this is the book we typically use, 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net, or there's a link in the description box of this video. It is an affiliate link, so I do get commission if you do get it. Also, I'm going to be doing a giveaway pretty soon here, man. Like I said, I've been saying this a lot on my channel, but I've been in talks with Boson NetSim, and I just looked at the thread with these people. I've been in talks with these people since like 2019 about trying to do a giveaway and stuff like that, because I was like, hey, I'm actually building a little audience here, man. Maybe I can try to do some giveaways and stuff. And at the time, I had just reached like 1,000 subscribers and stuff like that. Then I reached like 2,000 subscribers, and I kept growing and growing. I kept letting them know, hey, can I get some stuff so I could, do a giveaway or whatever. Apparently, I finally got a hold of somebody, like the marketing manager over there, and he said that the person I was talking to, he kind of left the company. So he's like, I'm sorry, we dropped the ball here, but here goes a bunch of stuff. He gave me a bunch of stuff, but those are the promotional stuff. But then he's going to give me some stuff so that way I can give away. So XM, their entire line of products, man. The XM, the exam stuff, the network simulator, the CCNA version, the CCNP version of that stuff. So I'm gonna be giving that stuff away. If y'all want to spread the word, let them know the NetworkBruh makes this stuff fun, man. And if they subscribe to my channel, they'll most likely get some free stuff. So I'm waiting till my milestone, I guess, is to get to about 5,000 subscribers. That's the next milestone. It ain't really much, but it's something. But yeah, I want to try to get to at least 5,000 subscribers, at least by the end of the summer, and then give some of that stuff away. And y'all know I'm going to be starting up the CCNP studies, because we're close to wrapping up this book, man. Again, we're on Challenge Lab number 5 here. Sorry, Challenge Lab number 6, page 491. As you can see here, I got 2 routers. Go ahead and drag and drop 2 routers, just like this right here. Hopefully you got Even G or GNS3. I got my man Sam over there. Appreciate you for tuning in. He's got Even G powered up. Go ahead and drag and drop 2 routers just like this, router A, router B. Cable them up. Y'all know I like using hardware. I like virtualization. I do. I like GNS3. Matter of fact, the Freestyle Fridays I use GNS3. And but y'all know I got all this archaic hardware here, and it's no longer being a museum. So I like to use my actual routers and stuff. So again, 2 routers, drag and drop them between. I got a serial cable between them both. They're already cabled up. I'm going to give it a couple more minutes for some people to tune in and stuff like that. And some people are going to be like, oh, shit, the NetworkBruh streaming on the Sunday? Let me go ahead and get ready here. We got Shashi9590. Appreciate you for tuning in. CD in the building. Let's do it. We got Johnny Nieves. Haven't seen you in a while. Appreciate you for tuning in. If you got Packet Tracer, well, yeah, Packet Tracer should support this feature. If you got GNS3, go ahead and fire that up. Go ahead and fire up CML. I'm going to wait for some of y'all to get tuned in and have your labs ready. Again, we only need 2 routers, so this should be pretty easy. There's only 3 tasks for this lab, man. These interfaces, right? We got to do a loopback, another loopback on that router, that physical interface, and this physical interface. That's it. We're going to do NATing here. So we're going to create a network address pool on one of these devices. I haven't gone over this lab yet, so I'm going to be doing it on the fly here with y'all. So y'all going to see some mistakes, if anything, and I'm going to reach out to you guys for some help if I do make a mistake. On router A, we're going to create a NAT pool, right? So y'all know, like, do pools in red, blue. So we'll create a pool here. We'll give them a little jacuzzi. And we're going to create a NAT pool. And when we send out traffic out of this interface, it's going to translate the public IP or the private IP address to a public IP address. Why? Because public or private IP addresses are not routable on the internet. I know this ain't really the internet, but this is simulating the internet. This is the wide area network, right? With my fake ass cloud right here. this is a wide area network, and only public IP addresses are routable on the internet. But here's another thing too. Paul Browning likes to use private IP addresses on both sides of his devices here. So this is a private address space. This is also a private address space. But we're just simulating this as if it's the private, public IP address space. So let's go ahead and get started. I think we got enough people tuned in, and hopefully you guys are caught up and stuff like that. We're going to go to router A, change him to router A, make him router B, and then configure these loopbacks, that physical interface, and that interface, right? That's task 1. You should, yeah, go ahead and configure those IP addresses as configured. That's not what he says on the actual lab. Yes, he does. He says configure the topology above, which is basically saying those interfaces. Y'all know my router is actually router 1 and router 3. So I'm gonna have to change those host names. If you don't know how to change the host name, it's all good. You'll be able to do it here now, right? You'll learn. Just go to global config mode, host name. That is probably the easiest task you'll learn. Router 1. I'm sorry, not router 1. He's router A. And we're gonna make him router B. You don't have to do this. You really don't. But y'all know I like following the book to a T. Luckily, I turned off the domain lookup there. We said his host name is gonna be router B, right? So we changed the host names. Now we gotta do loopbacks. That should be easy enough as well, right? Go to router A and say interface loopback 0. His IP address is address 192.168.1.1/28, which is 255.240, right? No, we don't need a no shut because the loopbacks come up automatically. Loopback 1. Right now I'm doing this guy right here. Right. Let me know if anybody has any questions. I know we just got started and stuff like that, but there might be some new people that'll be like, what the hell is a loopback? Is that like some kind of racetrack or something? I don't know. Y'all know my corny dad jokes. Loopback 1 is 192.168.2.1/27, which is .224, right? And then we're going to do that physical interface right there. The serial 00 interfaces. Your interfaces might be different. Mine is interface serial 000, just like that, right? And his IP address is 10.0.0.1, right? .1. Setting the mask of /30, which is .252. 252, right? You got any questions, right? It's 10.0.0, right? The X is a variable. Let you know it's either going to be a 1 or 2, which in this case, that's .1, and this guy's .2, right? For any of the newbies in here, right? And that's what that means, right? So he's 10.1. We're going to no shut that bad boy because the interfaces are shut down out the box, right? When we pull it out the box. Show protocol to check our work, right? He's 10.0.0.1, this guy right here. The other guy is 192.168.1.1/28. That's that guy. That's loopback 0, right? And then the other guy, loopback 1, is that right at 2.1/27, right? Y'all with me so far? Did I lose anybody yet? I'm sure I didn't, because you guys are all smart, man. If I can't get it, we got some smart people in the chat room that can help you out. Do you say what a loopback is? I've never heard of it before. Darth 3, good question. So a loopback is a virtual interface, right? It's kind of like a port, but we use it for testing purposes, or we also use it to create maybe different address spaces. So like this right here is a physical interface, right? I'll even show you, man. So the interface is the actual port. Let me pull out a router. Yes, I will do that for you, bro. I don't care how new you are, I'm gonna show you what it is, right? So that serial interface right there. Well, I don't have a serial interface. Let me see if I can pull one out. I want to show yeah, I want to show you just in case. Let me pull this guy out. I don't think he's plugged up. Router 4, right? Well, he's cabled up. Let's see how a serial interface though. No, he don't. Router 2 does though. Let me show you. I want to show you, man. I want to show you. I know some people like, man, I know what a fucking serial interface is, man. Like, so what, man? Just in case you don't know, right? Unplug that bad boy. That's the good thing about Packet Tracer too, though. You can actually see what those devices look like, right? Even G, you'll see the logical view of them, right? So here we go. This is what a serial interface looks like. That is a serial interface. That's what we got right over here. That serial 000 is right there. That is what it looks like, right? I don't know if you can see that or not. Yes, so it's plugged up to the other cellular interface of that router right there, right? So the loopback is a virtual interface. You can't touch it. You can't see it. You could actually log in and create it. We use it, again, it's on the fly. So you pop it, you turn it on, and then you can give it an IP address just like a serial interface and stuff like that. Again, we use it for testing purposes. If we want to create a separate network or whatever, and then let's say we need to ping this guy, right? That is the physical interface. He is in the 10 address space. Well, what if we want to ping something in a 192 address space? Then we either have to have another interface, but what if I don't have any more interfaces, right? This one only has 2 serial interfaces, right? This one has 2 serial interfaces that you can see. But the loopbacks, we can create as many as we want. We can create one in the 192 address space. We can create another one in the 172 address space. We can create a whole bunch of loopbacks, right? Whereas on this case, we only have 2 physical interfaces. So those are the purposes for a loopback. Now, I can't give you a official definition. We can Google that and check it out, but that, again, is why we're using. Plus, they're always up. That's another thing we can say about it. But, yeah, that's what a loopback is. So, he said, great way to spend my Sunday afternoon. Appreciate that, CD. We got Professor Black Ops in the building. Appreciate you for tuning in. He said, I wasn't doing anything, so I said, let's tune in. Yeah, for sure, man. So, like I said, I wasn't doing anything either. Actually, I was experimenting with a lab that we did on Friday, which was the first segment of Freestyle Fridays. We basically took all the topics we learned from Monday through Thursday, because y'all know I stream always Monday through Thursday, 8 p.m. Eastern Standard Time, right? And then Fridays, I typically don't stream, but I said I'm going to start doing, whenever I have a chance, we'll do Freestyle Fridays, where we take all the topics we learned from Monday through Friday, or Monday through Thursday, and then try to create our own topology and mix up those topologies and see mix up those technologies and see how they work with each other. Like this week, we're experimenting with NATing and ACLs and static routes and seeing how they all work, right? Well, we did all of that, and then I got stuck on a part on why it didn't work. For some reason, it didn't work, right? It was NATing. There was something with the NAT that did not work. Well, I finally was able to get it going after the stream, and I'll explain that to you guys in a little bit. So let's get back to this right here. So we got to do that physical interface. Go to router B, do that physical interface, and then move on to task 2. We only got 3 tasks for this, so go to router B, interface. We got to go to config mode. Serial. I'm sorry. Interface serial 000. Darth Dweeb, I hope that answered your question, man. But his IP address is 10.0.0.2 subnet massive /30, right? 252.255.252, right? No shut that bad boy. Check our work with show. I like show protocols now. I don't like show in the IP interface brief. That gives me the IP address plus the subnet mask, and it shows that it's up. Right, so we're good to go. That is that physical serial interface that I just showed you right now. We got Pater in the building. Appreciate you for tuning in, man. Let's go get that bag for sure, man. Really, we want to get that bag. We need to get in the cloud or cybersecurity, like my man Professor Black Ops over there, man. That's where the real money is, man. I mean, it's good, as a network engineer, we make some decent money too. Infrastructure and stuff like that. If you become a senior, you'll definitely make some money. But y'all know what it is. Come on, man. All right, so that was task 1, right? Configure those interfaces. No, we're still on task 1 because now he wants us to create a static default route on router B to send out traffic send all traffic out of the interface. So we got to go to router B, right? And then we're going to create, he says he wants us to create a static default route. Y'all know I always explain it the same way all the time, right? Static default route. So we want a route that is going to be going out of that interface right there, right? And when we say static, it means we got to manually configure it, and it's going only just that way, right? And when we say default route, we're saying any kind of traffic that you get any ingress traffic or any inbound traffic that comes in, destined for a destination or destined for a network that we don't know where the hell it go to, right? Send it out this interface. So we get any traffic that come in and it says, hey, it needs to go to the net. This packet needs to go to the 10.2 network, which is located in the 80.80.80.80.80 E76.70.1 network, right? We don't know where the hell it is at, right? Well, if we don't know where the hell it's at, let's just send it out this interface. And hopefully the router next to us or those other routers out there knows where to send this traffic. That is what a default route is, right? So we need to do that, and I'll show you how to do that. We go to global config mode, and we're going to say IP routes, because that's how we do static routes, right? And then the default route is, I like to call it quad zero route, because it's why? It's 4 zeros. And also, we do the subnet mask, right? It's all zeros. So that's why I like to call it the quad zero route, right? Now, we say either send it to the next hop, which would be 10.0.0.1, right? 10.0.0.1, or we can send it out that interface, which in this case, that's what they said. They said you should add a static default route on router B to send all traffic out of the serial interface, which in this case is serial 000 in my case, right? I know it says 00 there, but mine is 000 there, right? So your interfaces might be different. I know I say that a million times, but I'm just reminding y'all. Anybody got questions or anything so far? Or y'all let me know if I'm losing y'all or if I'm like making things more confusing or whatever. Task 2, right? No, not yet. It says here, test by pinging the loopbacks on router A. Check that you can ping all interfaces. Another reason why we needed to add this default route, right? I'm going to show y'all. I'm going to explain to you. I'm going to give you another reason why we needed to have this default route, right? I'm going to remove it real quick, right? We remove it with the keyword no at the beginning, right? That negates any kind of command you create, right? So we said we get any kind of traffic that comes in ingress, and we don't know what the hell to do with it, send it out this interface. That is what that default route will do, right? So let's take a look at his routing table right now. What networks does he know about? Show IP route, right? This router right here, router B, he knows about the 10.0/8 network, which is variably subnetted into 2 subnets, right? Which is the 10, basically the 10 network /30, and then this one is a local interface. Let me break this down for y'all, right? This right here says the 10/30 network. What's that? That's this right here. So that means he know about this network right here. Why? Because he got a physical cable that's fucking connected to him. That's how he know about this network. It's physically connected to him, right? So that's how he know about this network. What is this right here? That's what the C means, right? That's what the C means, right? Right here, look. We got a legend. It even says C connected. It's connected to us. This L means that IP address is locally configured onto this router. Where's the L at? L, local. It is locally configured on here. We typed it in and configured it, right? 10.0.0.2, right? Look. 10.0.0. I know it's an X there, but .2. That is what this interface is. It's locally configured on this guy right here. That is what he know about. So he know about this interface, obviously because we configured it, and he know about this network, obviously because there's a cable connected to it, right? That's what that means. So those are the only networks he know about, right? Well, let's say we get some traffic. So we can ping this. Theoretically, we should be able to ping it, right? From here to there, right? So we should be able to ping this guy right here. Why? Because we got, like I said, a cable that's connected to it. 0.0.1, right? We got to reply. Good. We didn't even have to pray to the network gods for that one. We got to reply. So we know it'll work, right? But what about these networks right here? These loopbacks. Shout out to Darth Tweet for that one. These loopbacks. He don't know about them, right? This is in the 192.168 network. That's in the 192.168 network. So guess what? He don't know about these networks. They're not in his routing table, right? I'll show you again. Show IP route. He only know about the 10 network because it's directly connected to him and one is locally configured to him. So he don't know about these networks. Well, that's where that default route come in. Any network that any packet that's destined for a network that we don't know what the hell to do with it, send it out this interface. And that is why we create that static default route and why they asked us to do it in the book too. So let's go ahead and do that, right? We're going to put that route back, which was what? That right there, right? Press enter. IP route, quad zero, send it out a serial 000 interface, right? I know mine says 00 there, but mine is serial 000, right? So now we take a look at our routing table, show IP route, and you'll see he still don't know. He only know about the 10 network, right? But guess what? We got this little S right here. What is the S? S is a static route, right? What does that star mean? Star means it is a candidate default candidate default, because we could have some other static routes. But the star lets us know, okay, we got some traffic here. We can send it out this interface. We can send it out this interface. We got this route. We got this route, that route. But this star lets us know this could be a default route. We could send any kind of traffic. We don't know what the hell to do with it. Send it out this, that route right there, right? So now, can we ping this? I should have, let me do this. I'm gonna remove it real quick, just in case anybody, might be new in here, right? I'm gonna remove it one more time, right? Now let's try to ping 192. We're gonna try to ping from here to there, right? We're gonna try to ping that right there, right? 192.168. Theoretically, it shouldn't, right? Because he don't know about that route, right? 1.1 ping. Get on our knees, pray to the network gods. It's hanging. It's hanging. Guess what? Our prayers are not being answered right now. Stupid phone. All right. So now we put that route back, right? I'm gonna keep putting it back and remove it just for us to explain that, right? So now we put it back. Show IP route. We don't know about the 192 network. We still don't know about the 192 network, right? But guess what? We have a route that's gonna let us know, hey, we got some traffic. Send it out this interface right here. Send it out that interface. We got some traffic. We don't know what to do with it. Send it out that interface. So now let's try to ping that IP address. What was it? 192.168.1.1, right? That right there. We tried to ping it. We got a reply. So fast, we didn't even have to get on our knees to pray to the network guys for that one, right? So he said, so you are sending all traffic to router B through your loopback connection? No, the other way around. I'm sending all my traffic from router B. Good question. I'm sending all my traffic from router B out of this interface. Unknown traffic. I should say you are sending all external network traffic through the loopback connection. No, because the loopback, router A, only he has loopbacks. Router B, this is router B right here, right? I'm still on router B. You do a show IP interface brief. I have this fast Ethernet. Those were not assigned. Those physical interfaces. They're both down. We only have this serial interface that I configured on it. Only router A had those loopbacks, those virtual interfaces I was talking about. So we go to router A and I'll show you real quick. Show IP interface brief. He got these two physical fast Ethernet ports, and he got the physical serial interface. Then he got these two loopbacks. We're looking at all those loopbacks from router B's vantage point. Does that make sense? Does that make sense? Let me know if that makes sense now, right? So those loopbacks are on router A, which is on the left-hand side. And then we're using router B to try to test. That's why we do it for testing purposes. I can remove those loopbacks and not have anything in the 192.168 unless I put it on a physical interface. So I hope that makes sense, man. Let me know. So we go back to router B. So we tested by pinging the loopbacks. We tested this one. We tested it going from here to there. We tested that loopback. Now let's try to ping this loopback right here. That makes sense? Okay, good. I'm glad you understand. Maybe I needed to do those arrows to make it a little bit more clear. So now we pinged 192.168.1.1. Now let's try to ping 2.1, right? This one right here. And hopefully that works. And we got a reply. Good to go, right? Remember last time we tried to ping this right here. It failed because we didn't have those routes. Once we put that route in, and then it worked, right? So now, task number 2. We only got 3 tasks for this lab. And Darth Dweeb, I know you asked some questions, stuff like that, but I hope you got your routers in GNS3 or even G or whatever you're using over there. You know, you got to do this along with us for you to really learn. Configure a NAT pool on router A. So we got to go to router A, right? So I don't get confused. I'm going to go to router A, and we got to configure a NAT pool, right? And in case you don't know what a NAT pool is, we'll explain that too. So we got to create a NAT pool located here. We'll locate it there, right? And then, so this will be the NAT pool. What are we doing with this pool? Are we going to swim in it? What the hell are we going to do with it? We going to take a bath in it? No. we're going to create a pool of IP addresses in it that we will stick our hand in to translate our address, right? So basically, because what we're going to do is, we're going to configure it on router A, right? So I know this is a private IP address space. That's private, and that's private, right? But typically, this will be a private IP address space, and this will be a public IP address space, right? That's why I don't like that Paul Browning likes to use all private IP addresses. But just make pretend that this is the private IP address. I mean, public, right? This is the internet, right? And this is the private, right? So, and when we're using NATing, what we're doing is we're translating an address from private, and when we get out of here, we're going to be in the public address space. The problem is you can't use a private IP address space in the public IP address space. That's why when you if you do what's my IP on your computer, you go to google.com and you type in what's my IP, it's going to give you a public IP address. Why? Because even though you have a public in a private IP address space, I don't want to show y'all. Let me show y'all. Fuck it. It's not like y'all gonna hack me, right? IP config, right? This is my IP address. Let's do the wireless one. Let's do the wireless one. We'll do that. We'll go with this one for now, right? That is a private IP address, right? My Ethernet connection, right? But when I go out to the internet, it's going to translate that to, well, at least the ISP will. He will translate it to a public IP address. So how do they do that? They do that with NATing, and that's what we're going to explain. That's what we're going to do here, right? So I'm not going to show y'all my private IP address. My public IP address for y'all to hack me and shit. But so that's what we're going to do here, right? So this is private IP, and when we get out here, it's going to turn into a public IP. But we need to pull from this NAT pool. We're going to take an address from the NAT pool and say what's our IP address going to be when we get out of this interface right here. Right? That make any sense? So how do I hack your IP? Man, I'm not answering that question. Get out of here with that, man. This dude. This guy, man. They boot you off of this stream, man. But a good question, though, man. But yes, there's ways to do it. And no, I'm not going to be, promoting that, man. Look at this guy, man. Never this guy. But anyways, so task 2, configure a NAT pool on router A. We've done that all week, right? So we're going to go to global config mode, and we're going to say IP NAT. We question mark, you'll see we could either do a pool, and then we could do source. We could do all this. Now, this is what I need to remember, and I keep forgetting. If we got to do the pool first and then the source. So I think we got to do both. Let's and then he says here, let's figure what else he says here. Configure a NAT pool on router A. The pool should consist of addresses 172.16.1.1 to 20/19. Now that's what I don't understand right there. That's what I don't get. Now, if we get stuck, that's what I love about this book. And if you're just following along, this is the book we're using. 101 Labs Cisco CCNA version 4. You get to copy this from 101labs.net, or there's a link in the description box below. If there is a solution guide if we do get stuck, but I try to refrain from using the solution guide and try to figure shit out myself, right? Because we're not gonna have a solution guide in life, man. or at work, we might, if there's a walkthrough or some kind of knowledge base or whatever. But y'all know what I mean. The pool should consist of addresses 172.16.1.1 to 20/19. I don't know what the heck he means by that. I don't know if that's a subnet mask or what. I guess that's a subnet mask. And it should NAT if any hosts from the 192.168.2.0/27 network, which is this right here, try to reach the internet, which in this case, this right here is simulating the internet. I know that's an ugly ass cloud and it's a black one at that, so that's bad luck. But that's what they're saying here. Overload the pool. Now, what do we mean by that? Overload means we're going to be translating the IP address, this address, to an address that we pull from this pool, right? But then once he gets out here, he's going to affix or append a port number at the end of it. And we do that, so it's basically he's going to add more addresses to it. If we just do IP address to another IP address, that's fine, but we could run out of those real quickly. So if we add in a port number to it, that's what the overload keyword is going to do, is add a port number to it, and then we'll have more addresses to pull from. So for example, they want us to translate this address to, I'll give you an example, 172.16.1, sorry for my bad handwriting, let's say 5, and then we're going to fix a port number to it and say, I don't know, 67. It'll be an arbitrary one. It's going to come up with one. You'll see. 6755. Now we got, not only do we have this unique IP address, but we also have a unique port number to it. So that gives us more addresses to pull from when we add this port number to the end. Does that make any sense? It's this dude, man, killing me over here, man, trying to hack. How do I hack your IP? This guy, man, you're killing me, man. Okay, so we need to create that pool. And I want to say we do IP NAT source first. We're going to do a list. We're going to create an access list for sure, because the access list, they specified what addresses are going to be using that pool. Otherwise, people in this network will be able to use that pool too. So that's why we got to come up with an access list. Does that make any sense? Remember, the access list just allows certain people or certain address spaces to kind of like, it's kind of like filtering. So what are we going to do here? So we're going to create a list, and I'm going to call it, we're going to call it ACL. We're going to call it NAT -ACL, which we're going to create one soon. NAT ACL 1. And then we're going to tie it to a pool. And we're going to call that pool, I'm going to say NAT Pool 5. I'm going to go with 5 and 5 because the last lab. So we have this access control list that we're going to create that's going to reference this right here. And then create a NAT pool called NAT Pool 5. We didn't create one yet, but we will do that in a second. Right? What else we got left? I think that's all you can do. Oh, that's right, the overload keyword. I forgot about that, see? And that's why I like question mark too, because I don't remember all the commands by heart. So now we do the overload. That's going to do an overload an IP address. So not only are we going to be able to pull from an IP address, we're going to append a port number to it. And that's what the overload keyword does, right? Press enter. So now, notice we got this NVI that came up, which is called a NAT Virtual Interface. It's basically kind of like an interface that does the translation and stuff like that. It's a legacy interface. Don't worry too much about it, but I'll leave a link in the description or a link in the... Oh, appreciate you for tuning in, Patrick. He said it makes sense to you. Y'all check out Patrick if y'all want to get into like some collaboration and stuff like that. Y'all know I usually do mostly route switch and stuff, but if y'all want to get into collaboration, y'all check out my man Patrick Canane. What else we gonna do here? So yeah, appreciate you for tuning in, man. And notice, like I said, we got this NVI that came up. This is another virtual interface, right? And I'll even show y'all. Remember what the interfaces we saw when we did show IP interface brief last time, right? We only had this physical interface that we created, or we configured. Then we got this physical, this virtual one, this loopback that I explained to Darth Dweeb, this other loopback. And then we had these two physical interfaces that we didn't even touch, right? That's why they're unassigned and they are administratively down. But now we run that same command, show IP interface brief. We'll see we also have this NVI 0. What the hell is that? That's a NAT Virtual Interface, right? Gave me the IP address, the same one as this. That's just letting us know kind of like where the translation is going to be occurring. So it's going to be kind of like occurring right in here, right? So that is kind of like the that's the NVI interface, right? I'll even show y'all. I think I got it somewhere in here. If you want a NVI interface, 0 interface, right? I got this from the, which one did I get it from? Cisco Community. I like this explanation. So if you want to kind of like go over that, I've never even seen this. Y'all let me know if Packet Tracer does this. But back when I was studying for the CCNA and stuff like that, I used to, you know, work with NAT and try to work with, I don't remember seeing this interface. It wasn't until I started using my hardware that I saw this. So it's, but again, it's a legacy interface. You don't really see that used much nowadays. So I'm that is a link for an explanation on the NVI. Son James is watching. Man, appreciate you for tuning in, man. Oh, he liked this little sound effect there, don't he? My daughter likes that too. So what else we was gonna do here? Patrick, can you put into below? Or can you put info below for Cisco Lab stuff? Yeah, for sure. Let me give you a link for. Do I have it in here? I probably do. I'm sure I do. I guess I don't. Shit, I used to have this on the fly, man. Also, y'all check me out on Discord server in case y'all want to discuss more stuff, or if something did not come clear to y'all during my stream. Y'all know I'll be just talking my head off, but this is a link for the Discord server. Sometimes I'll cancel my stream. I rarely do that. Or if I put some extra streams, y'all know typically I stream Monday through Thursday, 8 p.m. Eastern Standard Time. But if I do have, like, say, if I'm going to stream over the weekend, I'll let y'all know in the Discord server. So make sure y'all join the Discord server. Hold on. Thought I had it on here, man. I have to keep yours on deck, man. Just haven't seen you in a while there, Patrick. Put that in there. Yeah, that is Patrick's channel. So if y'all want to do some more collab stuff, y'all check him out. Let me put that on here too. So let's get with the let's get back on track here. So that was the natting. We created the NVI, or the iOS did at least. Now we also have to do an inside and outside interface. I'll be forgetting that. Now I'll try to remember that off the top. Right? What do I mean by that? We need to say we need to define where the translation is occurring from, and also where we're sending out the translation. The translation is going to be, right. So remember, we said we're going to be translating a. I'll go with this. Now let's go with that. We're going to be translating a private IP address to a public IP address, right? Well, when we do that, we need to say where those interfaces, where the translation is occurring, where it's occurring, from where, when the packets come in, and outbound. So in this case, they said they wanted, notice we don't have any physical interfaces here, right? We know this is going to be our outbound interface for sure. So let's do that, right? Go to global config mode, interface serial 000. The way we do that is IP NAT outside. So we know that is our outside interface. It's going to hang there for a little bit, and then it'll make it the outside interface, right? How we verify that? Y'all know I like to run show commands in the middle of my work to kind of make sure that when we're doing all this configuring, we don't miss any steps and stuff like that, and we make sure we're doing everything correctly, right? Remember I said, know your show. In this case, show IP NAT statistics. This lets us know who is the outside interface. It's even there in blue, right? Serial 000. I just did that. Well, guess what? I don't have any inside interfaces. Well, we only have two more interfaces that are on the inside of our network, right? It's either this one or that one. Well, we said we wanted this address to be doing some translation. So we don't need to do make him an inside interface. We needed to do this guy right here, right? We needed do this guy right here as the inside interface, right? So let's go to loopback 0. Oops. Go to global config mode. No, I don't want no sticky keys. Shut the hell up. Configure terminal interface loopback 1 and make him the inside interface. IP NAT inside, right? Y'all with me so far? We do that show command again, show IP NAT statistics, and we'll see we have a inside interface as well as the outside interface. So now we know where the translation is coming from. We got no translations just yet. Why? Because we didn't fully configure the pool yet. This guy right here. Nor did we yeah, that's pretty much it. We just need to do the pool at this point. Now, what I don't understand is their question, what the addresses consist of. It says 172.16/ Oh, okay. I think that's what he means. So he probably means two pools. That's what he means. I think. Because that's what I don't understand there. Because he says overload the pool, so that implies it's just one pool. Because what he said here is the pool should consist of addresses 172.16.1.1 to 20/19. What? I feel like Russell Westbrook right now. What? Man, y'all tripping. I'm gonna go look in the solution guide because I really don't know what he means by that. He put 20/19. What does he mean by that? What does he mean by that? I'm gonna have to look at the solution guide. I'm sorry, y'all. Not even gonna front for y'all. Like I know what the hell he means. So let me see. When he created the pool, he said 1.1 through 19. That makes, I mean, through 20. That makes sense. And that's it. I don't know what the slash, I don't know what he meant by 20/19. Unless that's a typo. Y'all correct me if I'm wrong. If anybody got the book, it's page 491, task number 2. He said to 20/19. I don't know what the hell he means. But I do see what he means on the solution guide when he says the range is from 1.1 to .20. And then the subnet mask is slash, what is that subnet mask? That's 16 plus 4. Okay, now I see what he means. No, I don't. Yes, now I see what he means. Now I understand now. Okay, so when he said 20/19, he meant the range is from 172.16. So let me write it out, but because this is not what the hell he said though. I'm gonna show y'all because I didn't understand it until I saw the solution guide. This is what he meant. The range of this NAT pool is gonna be, when we pull from addresses, it's gonna be in this range 172.16.1.1 through 20, right? And then the subnet mask is /19. That's what he meant. But he had the /19 and 20 together, and then it was in the next sentence. So that's what kind of confused me. But now I understand what he means. So let me see. He said, thank you for sharing the channel. I like how your channel's coming along. Man, appreciate you for tuning in, Patrick. He said, we got Endrit in the building, man. Man, listen, I think not the next stream, but Tuesday, I'm going to use EVNG. Just for my man, Endrit over there, man. This dude been trying to get me to use EVNG, and I'm like, no, I'm using my hardware. I don't care. Dusted off my hardware, cleaned it up, and using serial interfaces and stuff like that. But just for Endrit, I'm going to use EVNG on Tuesday. So go to global config mode. We need to create this NAT pool that we said right here. This NAT pool right here, right? So let me get rid of all this shit right here. Look like my daughter's handwriting, and I saved it, didn't I? What the hell? Let me erase all this because I don't want all that on there. I don't want all that on there. I didn't want that. Right? Do I have it saved? I think I do. NAT pool topology. Damn. ACL. No, don't save that. Pool, the NAT pool. Okay, good. I thought I did. All right, so I don't know why that happened. All right, now we need to create that pool, right? I know y'all been waiting on that pool. I'm leaving y'all in suspense. That pesky subnet mask. I know, man. Seriously, he put the way he wrote it. It was just weird. So, and then it was the next sentence over. So that's what confused me even more. So IP NAT. We create the pool with pool, right? Now we got to name the pool. What was the name that we referenced before? We said it was going to be NAT Pool 5. That's what we said it was going to be, right? Now we can create the pool. Start IP address was, he said 172.16.1.1, and then the ending address was .20, so 172.16.1.20. And then the net mask or the network mask was what he said? /19. So we could just do, I want to do prefix length, the prefix length. That makes it a bit easier because I don't want to do any subnetting right now. So 19, oops, not 199, 19. Good to go. So now we check our work with show IP NAT statistics. See what we got so far. Statistics. And that's the pool range. Start address is, so the first address we're going to hand out is going to be 1.1. We can hand out 1.2, 1.3, 1.4, 1.5, etc., until we get to 1.20. But remember, each time we hand out an IP address to it, because of that overload keyword, we're going to affix a port number at the end of it. So it's going to be like basically what they call a socket. So the first address theoretically should be handed out is, what's the goddamn brush, man? 172.16.1.1. .1 dot, let's go with, it's going to be .1, the first one that gets handed out. But let's say we up to .5 because the other ones were handed out already. We're going to put a colon and then affix a port number to it. 60, I don't know, 8 dot, or 6855, right? This is a port number. Obviously, this is an IP address. Those together create a socket. The reason why we do this is, remember, there's three types of NATing. There's static NAT, there's dynamic NAT, and then there's this, what this is called a NAT Overload. This is what we're doing here. Now, with static NAT, we're going to map one IP address to one IP address. That's fine and dandy, but that defeats the purpose of NATing because we're using one-to-one. That's called one-to-one NATing. And we can run out of IP addresses quickly because we're tying a public IP address to, a private IP address to a public IP address. We run out of them quickly. That defeats the purpose of it. Now, dynamic NAT is a little bit better because we're tying a private IP address to one that we pull from a pool, right? We created that pool that was over here, and we get an IP address from it, right? And then we're going to have that IP address mapped to a pool, right? That's cool and everything, but we can run out of IP addresses quickly too. That's just like, so this address is going to get tied to this address, right? That's just an example, right? That's cool and everything, but in order for us to have way more addresses available, we're going to add a socket. Add a port to it. So this address or socket is going to get translated, or this address is going to get translated to that socket. This concept is called NAT Overload, right? That make any sense? Now, usually anybody questions? If anybody have any questions or anything, let me know. Speak now or forever hold your peace. How can I get in touch with you because I deleted Discord and we have to fix secure CRT? You're right, man. You deleted Discord. I'm gonna give you my I think, didn't I email you? I can't even remember. I'm bringing that back up. But I'll give you my contact information in a little bit here. Nat Pool. Come on, man. Let me bring that back up. No, don't save it. And then bring back that Nat Pool. This Nat Pool right here. All right, good. I don't know why it keeps doing that. All right, so also I'm learning Python for network automation. It's awesome. That's what's up, Andrew, man. We need to get our automation skills up, man. Or owned by the network. He said that or owned by the network. What you mean by owned by the network? The IP address space? I don't understand the question. Darth Reed. So let's move on. We created that pool, right? Which was Nat Pool 5. This guy right here. We created the ACL. Now here's the tricky thing. This is what tripped me up on last stream. You create the ACL, but you don't necessarily have to tie it to an interface. Remember, you create an ACL, right? You need to apply it somewhere, right? You need to apply it to this. But guess what? We have this NAT pool that's going to be referencing this ACL that we created. It don't need to be applied to an interface. That's what I just learned today. Shout out to my man Kelvin Tran that cleared that up for me. And that's the reason why I got stuck on the Freestyle Friday stream. So now I think we pretty much done here, right? Overload the pool. We did that. That was task 2. Final task here, task 3. Check your configurations with show commands, which we've done with this show IP NAT statistics, right? We said we created the outside interface, which is 0000. That's our outside interface. If I can spell, that's our outside interface. We said our inside interface is loopback 1, right? This is our inside interface, right? Why isn't it this one? Well, because the book said use that one. All right, goddamn it. So this is our inside interface, right? That guy right there. This guy is our inside interface. What else does show IP NAT statistics tell us? It also tells us hit and miss. We didn't send any traffic yet, so that's why there's no translations yet. We don't have any NATing going from there to there. We didn't pull from the pool yet. Anytime anything matches our NAT rules with the ACLs and the pool and everything like that, then we'll see our hit counts come up, right? I don't know what the misses are. I'm not too sure. We can have expired translations. when we translate, right, they will come out of our translation table. We'll have a translation table, and I'll show y'all that in a little bit. And they get expired after a while because we want to reuse those IP addresses. So when we create that socket that we created earlier, like that one set where we set that example I gave you, that 172. Blah 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 blah, right? We might want to use that in the past, later on. So we make them expire, kind of like running out of DHCP addresses. We'll have a pool of addresses. Right, we might want to hand that out to somebody else. There might be a computer that held on to a socket, but you know, he went on vacation, he went on PTO, and Memorial Day coming up, so he hadn't used his PC in a while. We want to take that IP, that socket again, and give it to somebody else, for somebody that's actually working this weekend. Right, that's why we make them expire, just like DHCP addresses. Right, dynamic mappings. I think that's what all this is. Right, so that access list that we created. Right. He said continue with the show commands, right? Show IP access list. We didn't create the access list, so that's what we got to do. I'm glad we run our show commands, right? So we need to create NAT Pool ACL5. That rule is going to say apply it to this right here. We're going to permit this to use that pool. So that's what we're going to do here, right? So I'm going to use a extended access list. Go to global config mode. We say IP access list. We said we're going to name it. Well, we need to do whether it's standard or extended first. In this case, extended. And the name of it was going to be NAT Pool. I mean, not NAT Pool 5. Sorry. It was actually NAT ACL 5. Right? NAT ACL 5. We press enter. That's going to put us in NAT ACL configuration mode, right? So now we're going to say what? We're going to say permit. What are we going to permit? Translations or what? We'll permit anything, right? We'll say IP. That's going to encompass telnet traffic, EIGRP traffic, SSH traffic, everything, right? So we're just going to say that. IP, the source is going to be anything from this network right here to what? Anywhere, because they didn't specify what we're translating. So we're going to say IP, the source is going to be 192.168.2.0 network, right? That's what he said, right? Because he said it should not, if any hosts from network 192.168.2.0/27, that is this network right here. So not just that address, but the entire network /27, right? So in this case, 2.0/27, we don't do subnet masks when we're working with ACLs. We work with wildcard mask, right? Which is the opposite of a subnet mask, right? So in this case, we got to say 000. That last octet is going to be 255 minus 224, which in this case, y'all know my mental math ain't that great. So 255 minus 224, that last octet is going to be .31. So .31, and then we're going to say what's the destination. Destination is going to be any, because he didn't specify. He said we're just going to translate it to any, and then we're going to log our traffic. Press enter. Now we'll show our access list, show IP access list, right? This is what the access list says, right? The sequence number is 10, right? Because that number just showed up, because by default, when you create rules, it's going to be rule number 10, rule 20, rule 30, etc., etc., etc. In case you need to fix it, you can remove one line at a time. That's what's great about access control lists, for at least extended ones, right? The named ones. We're permitting any kind of IP traffic from the 192.168.2.0 network, this right here, right? The subnet mask of /27. But remember, with ACLs, we don't work with subnet masks. We work with wildcard masks, which is the opposite of a subnet mask. That is the opposite of it, 000.31. And it was saying, what's the destination? Any. So anywhere, because he didn't specify. And then we're going to log that traffic. That's going to let us know when something matches this ACL, go ahead and log it. Let me know when something matches that traffic, right? Y'all with me so far? Anybody lost, or anybody got questions or anything? Y'all let me know. There's no such thing as a dumb question. If I can't get to it, there's a lot of smart people in the chat room that can help out and stuff like that. Because remember, I'm trying to like do this lab, teach, hit the bruh sounds, look at this book, and pay attention to the chat room. To do all that stuff at the same time, yes, I can multitask, but it's pretty difficult. So if I can't get to your question, there's some smart people in the in the chat room to help you out. So we checked our ACL, that works. Oh, that looks good. We checked our NAT pool, that looks good. I think we should be good to go now, right? We have 20 addresses here. That's another thing I need to point out too. This address space consists of only 20 addresses, because that's what he asked for. We've allotted 0, so we didn't hand out any translations yet. Y'all run me that like button if y'all like what y'all see, man. And make sure y'all join that Discord server. Indra, I'm gonna reach out to you in just a bit about that that contact information. Let me hand y'all that Discord server, just in case y'all want to like have any questions after the stream, or if you like you too embarrassed to ask me, send me a DM, man. I'll let y'all know. I'll let you know what I know. So we did the ACL. What else we want to say about this Nat Pool? I think that looks all good. If we start handing out IP addresses, you should see this what's allocated go up, right? And that should go up to the percentage. So it's just like a DHCP pool. When we start handing out IP addresses, theoretically, 1 out of 20, once we start handing out, that should be about what? Not 10%, but like 2%. This should come up to like 2% or whatever. What else we need to do? Check your configurations with show commands and pings sourced from 192.168.1.1 when you have debug IP packet running on router B. So we need to go to router B. This last task right here. He wants us to turn on debug IP packet. So debug, this is gonna let us know what kind of traffic hits this router. So we're gonna, anytime something hits this router right here, we're going to log it, right? We're gonna see what's going on and shit like that, right? Packet, right? So now that's turned on. And now let's go ahead. He said ping, he said check your configurations with, he said check our configurations with show commands and pings sourced from 192.168.1.1, which is this right here. So he wants to basically send a ping from this and go out of that interface and hit like something like that. And then after that, I think we should be able to ping from here and look at the difference at what's going on here, right? So let's start with 1.1. Did he not say task 4 to? We should ping from both this and that, but he said to ping from that source, right? So let's go to router A. Ping. We're gonna ping this address right here, 10.0.0.2. So 10.0.0.2. Right. We're gonna change the source interface to that. Right. Otherwise, when we ping out of here, it's gonna use this as the source interface. Right. We don't want that. That's by default. Right. We want to source from this. Right. How we do that? We add the source keyword at the end, and then we do 192.168.1.1. Take a look at what happens. We got a reply. Right. Now let's take a look at our translation. Show IP NAT translation. Nothing there. Why is that? Because it's sourced from here. That, remember what our inside interface was, right? You remember what that was, right? Show IP NAT statistics. The source was the inside interface is loopback 1. So when we do translations, it should come from this. So now let's do the same thing, right? So when we translated, right, and we tried to hit that pool, we didn't even hit that pool. We kind of like bypassed the pool, right, and went across the wide area network, right? Now, when we come from this loopback, we're gonna jump in the pool first, and then pull an IP address with a socket. I mean, with a port number and overload, and then try to ping that, right? Theoretically, that's what should happen. So let's go ahead and pray to the network gods and change the source address to pool to, we're going to change it to 192.168.2.1. We could also do loopback 0 or loopback 1 if we wanted to, right? Source from 2.1. We got a reply. Now let's check our translation. Show IP NAT translations. We don't have nothing. So something's broken. We should have got a translation there, right? Let's take a look at that again. Yep. Here I am thinking we should have got something. Let's take a look at our configurations. We got something wrong here. Translation, not translations. The statistics. We said the loopback 1 was the inside interface. That is correct. Outside interface is 0.0.0. That's correct. The pool was this. We don't have to apply the ACL. Did we create that ACL that's going to allow the 2.0 network, /27? Let's take a look at our ACL. Show IP access list. 192.168.2.0, that is correct. Subnet mask of that, which is /27. That should tell us it's /27. We said destination any. Did we didn't get any matches. That's what happened there. We did not get any matches with this ACL. So that's one thing. Let me see. That ACL 5 is the name of it. Yes, that is the ACL he said he was going to use. Pool 5. So it's something with this ACL, I think we need to fix. Anybody see what I did wrong? No, this is not a pop quiz. I really did something wrong. We just need to figure out what it is. So I think it's something with this ACL. We're permitting IP traffic. Let's permit, and we're denying everything else. We have an implicit deny here, remember? So I think it's the ACL. It don't like that ACL. Let's go to that ACL. I think the pool is correct. But it don't like that ACL because we didn't get any matches there. We should have got if it matched, we would have got a log there. So let's go back to that ACL. So IP access list extended. The name of it was NAT-ACL5, right? Let me go back and make sure that was the name of it. Yes, NAT ACL5. That's what we're referencing. And when we named it, we said it was NAT ACL5, right? Yes, that's correct. So let's get rid of that rule, which is rule number 10, right? Someone say no 10, right? I'm going to create another one and say permit. We're going to permit. Let's do specifically ping traffic. ICMP. Sourced from 192.168.2.0, right? And then we got to do the wildcard bits, which is 000.31. And destination address, we said any. Who did I ping last time when I did that? I pinged 10.0.0.2, yes, and I changed the source to that. Okay, so yeah. Now we're gonna permit actually ping. And then destination, we're gonna say any, and we're gonna log that. Let's see if it likes that rule. Let's do a ping. Let's get out of this. Let's do a ping 10.0.0.2 source from we're gonna say loopback 1, right? So now we're gonna do the same thing and hope that it goes here from there, goes into the pool, pulls an IP address, and then go out with a different IP address and a port number tied at the end to it, right? He said maybe try with a standard ACL. That's a good idea. Shashi said in IP NAT inside source list. That looks better. I like that. Is that not what I did? Inside source list? Did I not do that? Let me see. I'm gonna press enter. I pinged it, but no, I don't have a match. So you're right. It might be my pool. Let me take a look at my pool real quick. Good. I like the way you guys are pointing this out. Let's do this. Show run section NAT. Take a look at what I got. IP, you say IP NAT inside. Oh, I didn't do the inside keyword. Shashi got it correct. I think that's the reason. That is the reason why I didn't put the inside keyword. I need to remember that. That is what I need to remember. Shout out to Shashi 9590 for that, man. I appreciate that. So, we don't have any translation, so we should be able to theoretically kill this. No, that's good. The pool is good. It's this that's missing the inside keyword. That's missing the inside keyword. So we can change this to IP, or we'll leave it as ping. We'll leave it as ping. So it's actually that key. This right here is what I need to work on. The pool is good. The pool is good. It's this is what I need to fix. So shout out to Shashi for that one. So let's go back to global config mode. We're going to get rid of this right here with a no to negate it. Do the same thing, but we're going to add the inside keyword to this right here. I'm going to do inside source. That should do it. Now let's try to ping. And I think it should work here, but we'll see. Ping. Let's try to ping it from this source right here first, which was what? Sourced from 192.168.1.1. Yes, that right there. Right? We do a show IP NAT translations. Nothing. Good, right? Because the ACL is not allowing him to. It doesn't match that rule, right? So, yeah, it does not match this rule right here. The ACL should match this rule right here, right? That rule right there, right? I'll show you. Show IP. Let me show you. So let me just show you, right? Show IP access list. That rule should match any ping. It's gonna say permit any ping traffic to the 2.0 network right here, right? with that subnet mask, or wildcard mask rather, and then that should allow him to go through. That's what that ACL says. And then he says log it when it matches. So it didn't match, that's why it didn't log. Now let's do it again. I'm leaving y'all in suspense here. He like, go ahead and ping the damn shit, man. All right, ping. All right, man, shit. 192. Sorry. So now we're gonna try to ping this guy right here, right? Right, 10.0.0.2. Source it from loopback 1, which is 192.168.2.1. Ping. And now we got a log. So shout out to Shotzi for that one. I was missing the inside keyword. Notice it permitted that right there. Right? We said 192.168.2.1 to it allowed him to go through to 10.0.0.2, right? So it allowed me to go through there, right? But that log does not give us information about us jumping into the pool and translating it to an IP address with a port number, right? Who tells us that? Show IP NAT translation should tell us that. There it is right there. So the inside global address is 172.16.1.1, right? This guy right here. Let me get rid of all this shit, right? That right there. I'm sorry. My bad. Inside global. Inside global address is, that is the inside global address. Inside global. I know you don't see it there, right? But remember, we have an NVI. The NVI that I referenced earlier, 172.16.1.1 is here. I know I didn't configure it, but 172.16.1.1. But he gave him the 16.1.1. And notice, Jesus, he's got a 4 at the end of it. What is that? That is the port number that I was referencing. And remember, the IP address plus the port number is a socket. So he gave him that socket. 172.16.1.1 inside global. What was this right here? Inside local address. What is the local address for him? 192.168.2.1.4. That's this guy right here with a .4 affixed to the end. .4. That is our socket number, right? Outside local. What the hell is that? Outside, remember, when we say global, we're talking about the wide area network, right? Makes sense, right? Global, wide area network. So this is the outside global. Inside global or outside global, I know it sounds kind of contradictory, or, you know, like it don't make sense, right? OL for outside locals, right? So the outside global address is 10.0.0.4, but notice it's the same thing here. If we had, like, say, a server or some kind of loopback or some shit like right back here somewhere, that will give them the outside local address. But we don't know anything behind that network. We don't know anything about it, so we gave them both the same IP address, or rather socket, right? 10.0.0.2 with the 4. So I was able to complete all that. I just need to remember the inside keyword. Hopefully you guys remember that. That is what I learned there. I'm starting to get better with the pools. I'm starting to better understand the that I don't have to apply the ACL. Remember we created this ACL right here? What was that ACL? This guy right here. NAT ACL number 5. We created that ACL. But typically you would have to, like, go to your interface, right? And then say IP access list and then apply that ACL to the interface, right? Well, with natting, we don't need to do that. This ACL is being referenced here. Where is it? With the show IP NAT translation, not translations, but the statistics. It probably expired. It expired. Where's the expired? We got the 1. That's why I didn't come across. See now, see how the allocated is at 0 because it expired. So now when we do show IP NAT translations, it's no longer there. So we got to do that ping again for you to see it, right? So let's ping it again. Where's he at? Ping it again. Now we show NAT translations. Now we got the translation. Now we do the statistics. And now we'll see we got 1 allocated. 5%. Right? That's so beautiful, man. I love this shit, man. So now, what else? When it works, at least. We got 20 hits, right? Because remember, when we ping, by default, we ping 5 times across, right? And I did the ping 5 times, right? 5 times what? Or not 5. We did it 4 times. So 5 times 4 is 20, right? That's why we got 20 hits, right? Remember? Right here. 5 times. We pinged it again 5 times, and then y'all remember the other ones, right? So I don't need to go up there and show y'all. What else I wanted to show y'all? I think that's pretty much it, man. Show IP NAT. We did the translations already. right? And then statistics. I like that command because it gives us a lot of information. This tells us that it was expired. Obviously, we do show NAT translations. You don't see no translations. That tells it expired too. But this lets us know that there was a translation that occurred in the past. So that's a great command to know when you're doing some NATing. Show IP NAT statistics. CD said maybe try with a different standard ACL. I could have done that too, but the main reason why this didn't work was what Shashi said. I left out that inside keyword. I need to remember that. So next time y'all want to lab with me, man, y'all get you a copy of this book, 101 Lab Cisco CCNA version 4. Like I said, we're going to move on to the CCNP version of this book because we're almost done with it. You can get a copy of this from 101labs.net, or there's a link in the description box below. It is an affiliate link, so I do get commission and stuff like that if you click over there. Experts agree that we retain only 10% of what we read. 10% of what we read. What does that mean? Inside one ear and out the other once you're reading shit, right? But, you only retain so little information. That's why I got to read stuff over and over again. I got to read it out loud to try to retain it. But when we're doing this stuff hands-on, we remember most of this stuff, right? I'm definitely going to remember that. I'm going to be like, oh, yeah, Shashi reminded me that I need to put that inside keyword. When I need to do the translations, it's IP, NAT, inside source, and then whatever we want to do. So, and that's with dynamic and static, I believe, right? No, with static you do, yeah. IP, NAT, inside source, static, right? For static ones, even though we don't really use static ones. IP, NAT, inside source, static, yes. And then for NAT overload, it's inside source, and then list, and then the list, and then the pool, etc. That's what I need to remember. Inside IP, NAT, inside source, they all pretty much start with. That's what I need to remember. So, when are you starting with CCNP? Good question. We are on a challenge lab number 6. So we just wrapped that up. What did he say? Yeah, he said issue an extended ping source from 1.2.1. And then he did another one from 2.1. Again, he didn't leave anything. So we just wrapped up challenge lab number 6. There are 15 challenge labs. Typically, I'll do like 2, maybe 1 or 2 streams. I mean, two labs in a stream. So I say we should wrap this up in about 3 to 4 weeks. There's some bonus labs in this book too, though. So there's labs A through G in this book. And then there's 2 appendices, which I'm not going to do because they're frame relay. I don't want to do that shit. So labs A through G, labs 7 through 15 is what we got left. Once we're done with that, we're going to move on to the CCNP version of this book. But we're also going to move on to some Boson NetSim. I'm going to do a giveaway once I reach 5,000 subscribers. And I'm going to give away some CCNA level Boson NetSim stuff. CCNP level Boson NetSim stuff. Also, some of their exam material. They're giving me a bunch of free stuff that I'm going to give away. And I'm going to give that stuff away once I get to 5,000 subscribers. So, y'all spread the word if y'all like my channel. Subscribe. Let people know I make this shit fun. And you learn when you actually watch this channel. So, for now, comment, like, subscribe to the network.